Welcome to today's grade 11 data handling lesson. My name is Mr. K. Mampolo. I'm going to take you through grade 11 data handling or statistics. Now, first, let's look into the measure of central tendency. So this is the summary measure that to describe a whole set of data. Like for instance, if in a test, most learners got 60%, there's high likelihood that other learners got the mark around that percentage. So that is why we say it's the summary measure that attempts to describe the whole set of data, like median. If the median mark is 60%, that can give you a clear indication as to how learners performed. So obviously, the word that is used more often, and you see it in your report cards, and that your educators will talk much about it when they talk about the class average. So after you have written a test, you'll be given a mark on your report card, and then the class average will be indicated. That class average will indicate as to how the whole class performed. So that is why we say all these three terms are said to be the measures of central tendency. I know you learned this word from grade 9, but I just wanted to take you through them. Now, like for instance, if you are given a data set like this, you see that 44 appeared 3 times, then it's our mode. So the mode is the number that happened more often, or the number that appeared many times. So the mean, mean is the average. Mean is the average. In this case, you just add all the scores. If these are the test marks in a test, the test marks in a class, then it means that you'll say 24 learners wrote a test. So you add all the marks, then the answer in this case was 1048, and then divided by 24, because 24 marks means we talk about the 24 learners wrote a test. So, and then it means this is 43,67. So you can see that we can say the class is average at level 3. So that is why we say these are the measures of central tendency. And if you check again, if you check the mean in this case, you'll find that the mean is 43,67, and also the mode is 44. So that is what I'm saying. This, you see that the marks are spread out, but you see that the mode and the mean are very close very close to each other. So if you see that mean is 43,67 and then the mode is 44. Let's look into the 5-number summary. Now, in this 5-number summary, then you will look at the minimum value, the Q1, which is the lower quartile, the Q2, which is the median, the Q3, which is the upper quartile, and the maximum. Now, let me remind you that when you determine the 5-number summary, you need to make sure that your data set is in ascending order. If it is not, you arrange them in ascending order. First thing, what you're going to do, you arrange them in order. Thereafter, you identify the first number, which is our minimum. Then from there, you determine the position of Q1. So there's a formula which is used to calculate the position of Q1. The Q1 is 1/4 into n plus 1. Then where n will be the number of test marks, or the number of learners who wrote the test. So here we have 24, then n will be 24 plus 1. Then the answer will be 6,25. Now, 6,25 is not necessarily the lower quartile. It's the position. But since it's not a whole number, you check the number, the whole numbers in which the position lies. Now, 6,25 lies between the whole numbers 6 and 7. So it means our Q1 will be number 6, term number 6 in this data set, and number 7, then you divide them by 2. But otherwise, if the answer was 6, we'll just take the term number 6. But here, because it's a decimal, then we'll take term number 6 and number 7, divide them by 2, add them and divide by 2. So same applies when you are doing the position. The position is the middle number. That is why the formula will be half into n plus 1. So now n is still 24, then you get 12,5. And again, since here you don't have a whole number, it means you check that 12,5 is between 12 and 13. So it means in this case, you take number 12 and number 13 and you divide them by 2. And obviously in this case it's easy because number 12 is 44, number 13 is also 44. Then when you divide by 2, you'll get the 44. Then 44 will be our median. Then Q3, remember Q3 is the third quarter. You say 3 over 4 into n plus 1, then n is still 24, then here you get 18,75, like we did with Q1 and Q2. Because 18 is not a whole number, it means you are going to take 18 and 19 because this position is between the whole, this is between the whole numbers 18 and 19. Then we take number 18, which is 61, and number 19, which is 63, divided by 2 to get the upper quartile. Then obviously the maximum will be the last number. Now this 5-number summary can be represented in a box and whiskers diagram. So where this will be the minimum, which is 12 in this case, then the next one will be as we checked, the next one will be the Q1, which is 27,5. You see it's around 27. Then you have a median, which is 44. Then you also have the Q3, which is 62. Then the maximum will be 95. So you can be required to determine the interquartile range. The interquartile range will be Q3, is the difference between Q3 and Q1. Then the range is the maximum minus the minimum. So the range is the difference between the maximum number and the minimum number. We know that the range, you learned about it from grade 9. Now, in grade 10, they will ask learners to determine the semi-interquartile range. Semi-interquartile range is the half of the interquartile range. So semi-interquartile range in this case will be 34,5 divided by 2. Now, skewness of the data. Now, if you have a box and whiskers diagram where the space between the Q1 and the median is equals the space between the median and the Q3, we say or when mean equals to the median, then we say there's a normal distribution. We say the data is symmetrical, meaning that the measure of spread out between the Q1 and the median is the same as the measure of the spread out between the Q2, which is the median, and the Q3. So if the mean equals to the median, we say the data is symmetrical or the distribution is normal. Now, if the mean is greater than the median, so normally the box and whiskers will be like this, where the scores between Q1 and the median are more clustered, while the scores between the median and Q3 are more spread out than they are on the left-hand side. So in this case, the mean is greater than the median, then we'll say the data is positively skewed or skewed to the right. So if the mean is less than the median, so this will be negative. I'm just trying to show you this so that you know that you don't have to draw the box and whiskers diagram to check whether the data is skewed to the left or the right. So you just say mean minus the median. So if the mean is less than the median, then it means this will be negatively skewed or skewed to the left, meaning that the scores between the Q1 and the median are more spread out than the scores between the median and Q3. You can see that between median and Q3, the scores would be more clustered, while between Q1 and the median, the scores will be spread out than they are on the right-hand side. So, but you can also determine that using a mean and median. If mean is smaller than the median, then you must know that the data is negatively skewed or skewed to the left. Now, let's look at the skewness example. So let's say you are given the data set of 11 terms as shown on this slide. Now, because the box and whiskers diagram is not drawn here, you can either choose to draw the box and whiskers diagram, calculating the 5-number summary, or you can just calculate the median, which is the Q2, and then you calculate the mean, because then you check the difference. If the mean equals to the median, you'll know that the data is symmetrical or the distribution is normal. If the mean is greater than the median, so it means it's positively skewed or skewed to the right. And if the mean is less than the median, it means it's negatively skewed or skewed to the left. So let's look into this one. Now, first, we'll get the position of the median. Now we say half, that's the formula. Remember, in this case, we are determining the position. We are not necessarily determining the median. Then you say half into n plus 1. And we have how many terms? 11 terms. 11 plus 1 is 12, divided by 2 is 6. It means term number 6 in this is a median. Then we count. We say 1, 2, 3, 4, 5, 6. It means 34 is our median in this data set. And then the mean, I will add all the scores, then I added them, then the answer was 484, then I divided by their number. They are 11, then we divide by 11, then the answer will be 44. So now we can say mean minus median. If the answer is positive, then it's positively skewed, or you can just say mean is greater than the median. If mean is greater than the median, it means data is positively skewed, or you can say it is skewed to the right. The outlier. Let's look into, let's just define an outlier. An outlier is the score or the mark or value in a data set which should be ignored when data is analyzed. It is therefore the score or mark or the value which is out of the ordinary. Now, let me take, for instance, if in a school in a class of maybe 40 learners, all the learners got the mark less than 40, and then one learner got 90%. If you are required to tell whether the school performs well or the school is underperforming, you can't only use one value, which is that 92% to say the school is performing well. No, the school is not performing. So it means that learner who got 92 is an outlier. He has that individual brilliance. Or there's a learner, there's something that this learner is doing that cannot be used to describe or to analyze the performance of the school. So we'll say learners are not performing. So, and we can't say because one learner is performing at 92%, then the school is performing. No, it means that 92 is an outlier. So we'll say the school is not performing. However, there's one learner who is doing exceptionally well. So when you analyze the data, if there's an outlier, the outlier is ignored because it does not give a true reflection of that Excuse me. How to determine the outlier in a data set? These are the steps. First, determine the interquartile range. Obviously, you have to find the Q3, find the Q1, then you find the interquartile range, which is the difference between the upper quartile and the lower quartile. From there, you determine the lower and the upper fences. So the lower fence would be in the Q1 minus interquartile range times 1,5. Well, the upper fence is equals to the Q3 plus interquartile range times 1.5. If one of the scores in a data set falls outside the fences, then it is an outlier. Let's look at this example. Now, you have a data set. In this case, you are required, suppose you are required to determine the outlier. The first thing would be to calculate the Q1 and the Q3. Obviously, first you have to determine the position. The position of Q1 is 3, then it means term number 3 is the Q1. Here you say 3 over 4, 11 plus 1, then it's 9. Term number 9 is Q3, which is 41. Now the interquartile range is 41 minus 26, which is 15. So as I said in the previous slide, to find the lower fence, you say Q1 minus interquartile range times 1.5. In this case, it will be 26, which is the Q1, minus 15, which is the interquartile range that we calculated here, times 1.5. The answer will be 3,5. The upper fence is Q3 plus interquartile range times 1,5. Then this will be 41. Remember, 41 is the Q3 or the upper quartile. And then interquartile range is 15. And then we say times 1.5. The answer will be 63,5. Now, let's check whether there is a mark or a score here which falls outside the fences. In this case, you see that 64 is not between the two fences. So if this is the case, then 64 is an outlier. As long as that score falls outside the fences, if you followed the method, then you will know which one is an outlier. So because 64 in this case, it falls outside the fences, then it's said to be an outlier. The variance and standard deviation. When you talk about the standard, the variance is the extent at which the data, the scores, or the extent at which the data set is spread out or clustered. So meaning the more spread out the data is, the greater the variance and the greater the standard deviation. So the more clustered the data scores are, the lesser the variance and hence the standard deviation. Why do I say hence the standard deviation? Because variance is the sum of the squares of difference between the score and the score and the mean square. Then it means you say the first score minus the mean square plus the second score minus the mean squared, then divided by the total number. And then standard deviation is the square root of the variance, meaning that if you calculate the variance, then it's easy to get standard deviation, because standard deviation, this is the symbol of standard deviation, and then is the square root of what? The variance. And then remember, this is a Greek symbol meaning the sum. It means you say the first number minus the mean squared plus the second number minus mean squared. All the numbers, all the numbers on the data set divided by their number. If they're 11, then you say divided by 11. Then the answer you get will be the variance. If the variance is greater, it means the data is more spread out. If the variance is smaller, it means the scores are very clustered. So standard deviation is the square root of the variance. So since standard deviation is the square root of the variance, it means the variance is the standard deviation square. Now, as I said, if you are doing the long way, first you'll calculate the mean, adding all the numbers. Then after that, you divide by 24, and then the answer will be 43,67. Then the mean or the average mark or the average score, it will be 43,67. Now from there, after you've calculated the mean, as I said, you say the score, first score here is 12. 12 minus 43,67 all squared plus 18 minus 43,67 squared plus 17 minus 43,67 squared, all of them. Then from there you divide by 24 because they are 24. So remember, this 24 must be inside the square root. It's part of the square root. So then the answer you get, it will be, our standard deviation will be 20,34. So it means the variance will be 20,34 squared. You can also calculate this without using this long method by using a calculator. And remember, even if you use a calculator and get the answer only at the end of the in the final exam, you'll definitely get full marks. As long as your mean is correct, standard deviation is correct, doesn't matter whether it's 2 marks or 3 marks, you get full marks for it. So don't worry about getting only the answer when you calculate the mean and standard deviation. So you can use a calculator, get the answer, and get full marks. So what you do, if you are using a Casio, you press mode, you press 2, you press 1, then it will give you a table, then you enter the data scores. So meaning, say 12 equals to, 18 equals to, until you enter the 95. So you enter all the scores. Then from there, you press AC. AC means you are saving the data, meaning that after you have calculated the mean, there's no need to start from scratch. You just go on and get standard deviation without entering the data scores again. Now, before that, then after saying AC, like I said, you say mode, press 2, press 1, enter the scores, press AC. Then if you say shift, press 1, press 4, press 2, then equals to, then you will get the mean. Then, because you pressed AC to save the data, you don't start from the beginning. When to get standard deviation, you go back to shift, you say shift, press 1, press 4, press 3, and then you say equals to. The answer you get will be the standard deviation. If you can just use a calculator, you'll see that for mean, you'll get 43,67, and then for standard deviation, you're going to get 20,34. Now, there's this question that they will ask at the end of exam, where they'll ask you whether there are numbers which are falling within or outside first or one standard deviation. So what you'll do, calculate the mean, calculate the standard deviation. So then you'll get the upper limit and the lower limit. So this interval will be the ones that you will determine the number of scores falling outside one standard or the first standard deviation, or they're falling within. Now, we got the mean, you get the standard deviation. The lower limit, you say mean minus the standard deviation. The upper limit, you say mean plus standard deviation. That is why you say the mean plus or minus the standard deviation. Then you will get the interval. So all the values falling between two limits so are said to be falling within one standard deviation, meaning scores from 29 to 63, all of them, they fall within one standard deviation because all of them are between these two limits. the upper and the lower limit. So 69 and there's only scores which are not falling falling within. They are falling outside of this. And sometimes they will not say how many, say, what is the percentage of the scores which fall within one standard deviation? Here, how many are they? They are 9. It's from 29 to 63. They are 9, 2, 4, 6, 8, 9. Yes, they are 9. Then if you want to know the percentage, you say 9 over 11 times 100. Then the answer will be the percentage of the scores which fall within one standard deviation. So if they say, what is the percentage of the scores which fall outside one standard deviation? You say there are only 2. Then say 2 over 11 times 100. And sometimes they'll play with weights. Like, for instance, they can just say the learners who perform below one standard deviation are said to be the high-risk learners. So then they ask you a question and say, how many learners are considered to be high risk? So because they said learners who perform below one standard deviation. So we'll say, okay, below, then it means we are only going to consider the first value. Is the first value less than or greater than the lower limit? No, it's greater than. So there's no learner in this case who perform below the first standard deviation. It means none of the learners in this data set, if we talk about the learners marks. So we say none of them. But if they say the learners who perform above first standard deviation are said to be high flyers. What is the percentage of the learners who are high flyers? You say, oh, those who perform above one standard deviation, then this will be, there are 2. Then you say 2 divided by 11, which is the total number, times 100. Then that will be the percentage of the learners who are said to be high flyers, according to the statement that would have been given by, about the data set. Now, if they say how many if you want to determine the number of learners who perform within or outside second or 2 standard deviations, we do the same thing, lower and the lower limit and the upper limit. The difference is that now here we say 2 times standard deviation. So we say 2 times 19,2, and then here we say 2 times 19,2. Therefore, the lower limit will change to be 5,6, and even the upper limit will also change. So what does this mean? It means that in this data set here, in this one, it means 10 learners performed within one standard deviation, because from 29 to 65, they're between 5,6 and 82,4. It means only one learner performed outside the second or 2 standard deviations. Continuous data. This is the data set which does not represent the exact numerical values, but frequencies within the certain ranges. For instance, if I want to check the number, the ages, the age groups of parliamentarians. Then I go to the parliament, then I said, honorable members, how many of you are between the ages of 20 and 30? When they raise up their hands, I find that maybe 10 of them or 11 of them are between the ages of 20 and 30. I don't exactly know their ages, but I know that the 11 parliamentarians are of the ages between 20 and 30. So I do the same, 30 and 40, they raise up their hand and I count the frequency. So that is why I say this is a data set which does not represent the exact numerical values, but frequencies within certain ranges. I gave an example that determination of number of learners between of 14 and 20. If we say they are 60, we are not necessarily interested in the age of the learner, but the number within that range. Now, remember, this can be represented as a frequency table or the histogram. Remember, histogram is used to represent the frequency table, and then the cumulative will be represented by Ogive diagram, which will be discussed in the next slide. Let's say you're given something like this, then the question say complete the table. Let's start with the frequencies. You look, the age ranges are determined by the bins. Remember, in this case, the bins are connected. So, and then we'll say from 20 to 30, then how many are they? Then the number here is 8, frequency is 8. From 30 to 40, you see that is 16. From 40 to 50, you see it's 34. Then you keep on calculating all this until the end, like this one at the end here is 12. Now, when you calculate the cumulative frequency, obviously, when you say you are doing it cumulatively, you add as you go, meaning you'll be counting, finding that first one, there are 8. Then when you say the next group is 16, then you say 8 plus 16, then it's 24. When you check the next group is 34, you say 24 plus 34 is 58. The next group is 56. You say 58 plus 56 is 114. The 114 plus 44 is 158. Then that's how to get the cumulative frequencies. So, but at the end, we know that if we are talking about the learners, it means we are talking about 194 learners are the ones who participated. Modal class or modal group. Since in a continuous data, we don't have the exact values. So we can't find the mode, but we can find the modal class. A modal class is the class which high frequency. In this case, you can see that the ages between 50 and 60, there are 56. So this is the highest frequency than any other group. So it means we are going to say 50 to 60 is the modal group or the modal class. We don't say the modal class is 56. No, we say it's 50 to 60 because the frequency is higher than any other group. Is higher than the one in any other group. So it means 50 to 60 is the modal class. Now, in a continuous data, we don't have the exact mean or the actual mean. We have the estimated mean. How do you do that? First, you find the midpoint. Say 20 plus 30, which is 50 divided by 2. Then it's 25. Then say 25 times frequency. That is why we have 25 times 8. So the next one, say 30 plus 40, 70 divided by 2 is 35. So you say 35 times the frequency, which is the 16. So you keep on doing that. The third one, you say 40 plus 50 is 90 divided by 2 is 45. Then you say 45 times 34. Then you do that in all of them. Then you divide by the total, which is number of learners or the number of parliamentarians or whatever that will be collecting. Then you say 194. Then the estimated mean is 56,96. This is not the actual mean. It's the estimated mean. Now, Ogive diagram. Remember, I told you that when you draw the histogram, you use the frequencies. But when you draw the Ogive diagram, you use the cumulative frequencies. Now, How do you do that? First, the 20 upper limit of the first interval is where the graph will be grounded. It means the graph will start in the horizontal axis where the value is 20. So it means it's grounded at 20. It's very important to get your grounding correct because there's a mark for grounding. If you get your grounding incorrectly, then you may lose marks in the test. Then the first plot, then you use the upper limits and the cumulative frequency. It means the x value will be 30, the y value will be 8. I'm just saying x because now we know that we used to name the horizontal axis on the Cartesian plane as the x-axis, the vertical axis as the y-axis. So we'll say the x would be, you'll plot where x is 30 and y is 8. The next one you plot where x is 40, y is 24. The next one you plot where x is 50, y is 58. The next one you plot where x is 60, y is 114, and so on. So, but most importantly, don't forget that the lower limit of the first interval is where the graph will be grounded, which is 20. You can see that the graph starts as 20. These are the plots. Remember the plot, it will be the upper limit of every interval and the cumulative frequency, not the frequency. The frequency can be used in a frequency polygon, can be used in the histogram, but it cannot be used in an ogive or ogive diagram. So then you plot the points. Another thing that I want to bring it to your attention. Normally, when we mark, we find that most learners will join the points using a ruler. That is not acceptable. So when you join the points, never use a ruler. It must be a smooth curve. Just use a hand, because if you use a ruler, then you lose marks. Now, you can also be required to use ogive or ogive to estimate Q1, median, and Q3. Now, Q1 is 1 over 4 plus 194 plus 1. So, and remember, we want the position here. We'll say Q1, 1 over 4, as we did with the previous one. Then N is 194. N will always be the total. Remember, the last number there was 194 plus 1. You'll get 48,75. Then you'll check where 48,75 is. Then it's here, roughly. Then you draw a horizontal line. Then when you get to the graph, you draw a vertical line. Then on the x-axis, that value that you get, the value that you get will be the estimated Q1 on this ogive. So then it will be 48. But remember, because it's an estimated value, if you write 47 or 49, it will be accepted, because they know that some may find that your graph, your line was not straight, then it affects the exact value. So since you are estimating, the closest value will be accepted. The median, you do the same thing, then you'll find that the position of the median, you know it. 194 plus 1 divided by 2, you get 97,5. Then you check where 97,5 is. Somewhere here, you draw a line, then you draw a vertical line. Then the answer here will be something like 58. So we can accept 57 and then 59. Q3 is the formula as we did, the total, which is 194 plus 1, you get 146. Then you go to 146 somewhere here. Then you draw a horizontal line, then you draw a vertical line. Then you'll get something like 67, and then you'll accept 66 and 68. Also, you can also use this to find the percentiles. 90th percentile is a 90 over 100 into 194 plus 1, then you get 175.6. Then you will just go here as you did, draw a line, then the answer here, it will be your 90th percentile. Then this will be 75. You can accept 74 and 76. And it's not always the case that they'll say calculate the values on the x-axis. You can be required to calculate the values on the y-axis, which is the cumulative frequency. They can say, if we talk about parliamentarians, they can say, estimate the number of parliamentarians who are 40 years. Then you draw a line here at 40, then you draw a horizontal line. Then you find that something like 24. You can say 24 parliamentarians are of the 40 years of age. But remember, this is the estimated, not the actual ages of the actual number of parliamentarians who are 40 years of age. You may find that none of them is 40. But now, again, sometimes they can say, determine the number of parliamentarians who are over the age of 60. Who are over the age of 60. Say, okay, the age of 60 here, there are 100. The total is 194. Then we say 194 minus 100, because we are saying determine the estimated number of parliamentarians who are over the age of 60. So you say, you check where age of 60 is, then you say 100, which is the cumulative frequency. Then because you say over, then you say 94 minus 100. Then this will be the estimated number of parliamentarians who are over the age of 60, then which is 194 minus 100. Work example 1. The sample of residents were asked how many liters of water they use per week in their household. The results are summarized as follows. Then here you are given the frequency, the number of liters, the intervals versus frequency. Complete the table in the next slide. So when you determine the midpoints, we are referring to the midpoints of the intervals. It means the first one will be 50 plus 100 divided by 2, then the answer will be 75. 100 plus 150 divided by 2 is 125, and so on. Then you keep on doing like that. So we know that cumulative frequency, you calculate them from the frequency. 20, here's 20. 20 plus 30 is 50. 50 plus 50 is 100. 100 plus 100 is 200. 200 plus 80 is 280. 280 plus 70 is 350. 350 plus 50 is 400. It means we talk about 400 users. We talk about 400 users of the users of this water. Now, here is the frequency that times the midpoint. Then we'll say 20 times 75. You get all these values. 30. We know that these are you do like this when you calculate the mean. So by so doing in this table, now it becomes easier when you calculate the estimated mean, because you'll not say the midpoint times the frequency. Already you have calculated them here, and the total is 100,000. But the total number of users is 400. So this will be 100,000 liters used. And then here it will be 400. Calculate the estimate of the mean of the liters of water used by each household. Because already we calculated the product, the sum of the product of the midpoint and the frequency, which is 100,000. Then you just substitute 100,000 divided by 400. Then the answer will be 250. 50 liters. Draw an ogive. Let's not forget that when you draw an ogive, this one, 50 will be where it will be grounded, 100 will be the X value, and then 20 will be the Y value. Just like that. The next value will be 150 and 50. The next one will be 50 and 100. But most importantly, the graph will be grounded at 50. Calculate the estimate of the mean liters. We did that. We draw the ogive, as I said. The graph will be grounded at 50. And then you plot the points. You plot the points, and then don't forget that when you join the points, you are not using a ruler. Must be a smooth curve. Join the points just using a hand so that it will be a smooth curve. Use the ogive to determine the median of the data set. As we know that the total is 400, it means the median will say 1/2 into n plus 1. N will be the total. In this case, it will be 400. Then it will be 1/2 into 400 plus 1. So it will be 200 point something. So you'll have something like 21. Then so you check here at 200, then you draw a horizontal line. Then when you draw this, it will be the median number of liters, it will be 250. Comment on the skewness of the data. Give the reason for your answer. Remember, we calculated the mean as 250. Then we also calculated the median as 250 liters. So it means the mean equals to the median. And if the mean equals to the median, it means the data is symmetrical or the distribution is normal. The municipality restricted the water usage due to water shortages. The residents may not use more than 300 liters of water per household per week. How will this affect standard deviation? Explain your answer. This is the question which will be in the last one on the grade 11 part of data handling. So here they want to check whether you can think out of the box. So you may find that some of you will say standard deviation will increase, or some will say standard deviation will decrease. So it will depend on how you justify your answer. For instance, you can say the standard deviation will decrease. The reasons being simple, the values will be closer to the new mean. The values will be more clustered and less spread out. Remember, I told you that the more clustered the data set, the scores are, the lesser the standard deviation. So if those who were using up to 400 liters now move to 300 liters or below, it means the data will be a bit clustered. Or other learner may say that the standard deviation will increase. Now, remember, you calculate the new mean. You may find that those who are using, like in the places like in the car washes where they use more water, you may find that someone says those who are using around 400 liters of water, they will go down, but they will be at exactly 300. They will be at the what you call the upper limit. So now one can say the most of them, they will be at 300, and there will still be the difference between the scores and the new mean. Then if there's a greater difference between the new mean and the scores around 300, so it can make the standard deviation to be higher. So it means when you have this kind of question, you have to think out of the box, give your answer, and give reasons for your answer. You may find that your some say standard deviation will increase. As long as your reasoning is correct, you can get marks, and others may say standard deviation will decrease, and they'll give their valid reasons. But don't leave space. Now, the next works example, during a congress that took place in July, the ages of 100 members who attended were recorded in the following table. Then we have the age ranges versus the frequency. The first question, calculate A. Now, let me tell you, if you are given a frequency table where we have unknown values, they cannot say calculate unknown values without giving you something on the statement which will help you to get unknown value. Like in this case, you are given that there are 100. So, and then, but we don't know the age range between 55 and 65. What you do, you'll say, okay, when you add the numbers, they must give you 100 because the total was given to say during the total number of members who attended, they are 100. So it means to get A, you say A is 100 minus the other scores in the other rows or in the other rows, then you'll get the value of A. We know that. So meaning if you they give you on the statement, they give you for instance, they give you the mean. The first thing that you're going to do, you will use the formula for the mean because you were given the mean. Then you will say we know that how to calculate the estimated mean. You find the midpoint here, which is 15 plus 25 divided by 2. Then we get 20. Then you say 20 times 8. Here you'll say 30 times 14. Here you'll say 40 times 22. Here you say 50 times 37. Here you say 60 times A. Then here we have say 70 times 3. Then you say it's equals to the mean given on the statement. Then you solve for A. So they can't just give you the unknown value in a frequency table without giving you something on the statement that will help you to calculate that unknown value. Now, we calculated A. We say A is equals to 100 minus 8 minus 14 minus 22 minus 37 minus 3. Then A is equals to 16. Now, write down the modal class of the data. Obviously, you see that the age range between 45 and the interval between 45 and 55. The frequency is 37. So there is no other interval which has higher frequency than 37. So it means the age range between 45 and 55 is our modal class or the modal group. Write down the modal class of the data. We did that, which is between 45 and 55. Complete the cumulative frequency table. You know how to do it. The first one will be 8. The second one will be 8 plus 14, which is 22. The next one will be 22 plus 22, which is 44. The next one will be 44 plus 37, which is 81. The next one will be 81 plus 16, because now we know the value of A, which is equals to, and let me tell you, even if you get A wrong, we are going to use what you call CA, continued accuracy. So it means we'll check whether you continued correctly with this wrong value. Then if you did it correctly with this wrong value, you still get the full marks, because we know that at the end of the year, we penalize you only once. So if we penalized you in the first one, if you do the things correctly in number 3, so that wrong A value which is substituted, if you follow the right procedures to calculate the cumulative frequencies, then you'll get mark out of that. But it does not mean that you have to make mistakes just because you say we'll get marks even if you made mistakes in the first one. Draw a cumulative frequency graph or OGIF to represent the data. Like I said, the first one, 15, the upper limit in our first interval, it will be where the graph will be grounded. Then the lower limit, which is 15, and then the other points to plot will be the upper limits and the cumulative frequency, meaning that plot where x is 25, y is 8, where x is 35, y is 22, where x is 45, y is 44, and so on. Then your graph will be like, as I told you, that the lower limit of the first interval will be where the graph will be grounded. Remember, if you mess up your grounding, you lose mark for it. So make sure that the lower limit of the first interval is where the graph will be grounded. And also don't forget that if you use a ruler to draw the frequency cumulative graph, you lose marks. It must be a smooth curve. You use a hand. The Congress organizers discovered that mistake was made, and then that 3 people counted in the range 45 to 55 should have been counted in the range 35 and 45. Calculate the estimated average age of the people who attended the Congress after the mistake was corrected. Here, they just want to mess up with your head. What is happening here? They just said 3 were supposed to who were supposed to be in the interval between 35 and 45 is in interval of 45 to 55. Then you just subtract 3 from this 45-55 interval, and then you add 3 to 40. You add 3 to you subtract 3 from, let me just quickly show. Okay, you'll add 3 to the interval between 35 and 45, and you subtract 3 from the interval between 45 and 55. So, but remember, even if you just calculate the mean as it is. Remember, the question says you calculate the estimated average. Remember, average is the mean. Now, if now you calculate without subtracting, you are still going to get the marks. But it was just a simple thing of saying we are supposed to put 3 participants in this group. You just remove 3, subtract 3 from this age group and add it to that other age group. So that is why now we say the midpoint here is 20, 6 times 8. Then we say the midpoint here will be 30 times 14, 40 times 25, and then 50 times 34, 60 times 16, and then 70 times 3. Then you get the answer. Then it will be 44 over 50 over the 100. The 100 is the total. Then remember, the total of 100 was given from the initial statement. Work example number 3. 50 athletes need to access suitable training facilities. The table below shows the distance in kilometers that they need to travel to obtain the suitable training facilities. As you see, this is the frequency table. Complete the cumulative frequency table. First one is 3, 3 plus 7 is 10, 10 plus 20 is 30, 30 plus 12 is 42, 42 plus 5 is 47, 47 plus 3 is 50. Then we have total of 50 in this case. That will be our cumulative frequency. Draw an OGF diagram. Don't forget that the lower limit of the first interval is where the graph will be grounded. Since it is 0, it means the graph will be grounded at 0. The points to plot will be 5 and 3, 10 and 10, 15 and 30, 20 and 42, 25 and 47, and then 30 and 50. So, but the graph will be grounded at 0. Now, you join the points using a pen. So you don't use a ruler. You join the points, then you find the ogive diagram. If your ogive diagram is not an S shape, you must double check. There is something that you have done wrong. Or the ogive will always be an S-shaped graph. The next one, calculate the interquartile range. Interquartile, you have to calculate the Q1, and you calculate the Q3. You find the lower quartile and the upper quartile. So in this case, you are going to say upper quartile, you say, remember the total is 50. What is 75% of 50? Then it's 37,5. Then we draw the horizontal line. When you get to the graph, then you draw the vertical line. You'll find that you'll get something like 17 as your upper quartile. The lower quartile, we say what is the quarter of 50, which is 12,5. Then you draw the vertical line. You find that is 11. Yeah. So remember, in an ogive, we don't find the exact values. We talk about the estimated values. If instead of 11, you got 10 or 12, it will be accepted because these are the estimated values. Even that one of 17, it can be 16 or 18 because these are estimated values. Then the interquartile range will be Q3, which is 17,8, and then Q1 will be 11. Even if you just say 17, it is correct. If you say 16 is correct. If you say 18 is also correct. So because these are the estimated value. But most importantly, you must know that the interquartile range will be the upper quartile minus the lower quartile. The closing remarks. If you didn't get it right yesterday, it doesn't mean it is impossible. Do it again and again till you get it right. Thank you so much. Let us keep on subscribing, and then we'll keep on sharing the videos of other topics, and as we'll be preparing ourselves for prelim exam and the final exam. Enjoy the rest of your day.